Welcome back. Welcome back. We are busy with the PLC. We are busy with the PLC. So now, what we want to do, we want to look at how we looked at latching, and I said I wanted to dwell on the latching only and not stop, just so people can understand the concept of latching as staying on after a start button has been released. All right, so now we want to see how we can complete that latching now, but introduce the stop function. All right, now I want to introduce the stop function. So now what we'll do is again open our program, WPL soft, and there, give it some time, then there it is. So again, we can do whatever we want. A new programming platform. So what we're going to do is we're going to give it a title. We are going to say understanding stop function. Understanding stop function. I will come here and say I will name this Delta PLC basics, the stop. All right, I will call it that. Now I will have to choose the PLC we have. We already said we are using the SS2. So there is SS2. Everything else is not really an issue now. We can go on and say there is our platform. We want it big, nice and big. So we go and say, let's look at this. What we're going to do is we know that to start we need a normally open. Now we understand what a normally open is. So I'm going to say F1 function, F1. Remember the function button, F1. It gives me that option, and then I say that's my start. All right. So I will call that start. Remember the comment. You have the option of showing the comments or not showing them. You just go to view. If you think they are making your space a little bit messy, you can actually come and say device comment, use device show comment. Yes. So you can come and say I don't want to show the comment. Now you see the start has disappeared. But if I want to see it, I prefer to see it. So it's up to you. I want to see it, so I will say stay there. Now the start is a normally open. One would assume that the stop power goes through the stop all the time until you stop. So one would assume that the stop will therefore be normally closed. So let's go and say normally closed, which is F2. I can say function F2, and there I will say X0 was my start. I want it to be different, so I'll say X1 is my stop, and then that's my stop. Then I'll say I want simply to run my output. My output is, okay, I'm gonna say load, not load out, and then that will be Y0. All right, so now I'm doing it different. So remember, Y0 needs to be able to keep itself on once we've released the press and release button, which is the start. Therefore, we need to what? We need to come there and say I want a normally open, which is going to be the same as Y0. Y0, because remember we said the machine has to have a contact, a way of keeping itself on, so it has to be the same as the machine itself. I didn't name this. I supposed to say machine. I want it to be the same as what we did last time. We said machine A. So now if we do that, we can see that we have machine A there, and machine A is parallel to the start. So what we have an either or pathway. Okay, either that way or the other way. So now I come there and I say let's complete the parallel, remember parallel must be connected on one side and on the other side. That's how things are parallel, connected on one side, and electrically parallel means yeah, lingually parallel means that they never come together, right? But electrically parallel means that they are connected on the one side and connected on the other side, right? So now then you can see that you have a parallel set for x0 and y0 there. So it means that the machine, one of the contacts of the machine are able to keep it on. Remember the latch. If you can't remember it, go back to our session on the latch. Now we have a stop function. Let's see if we simulate this. Now we simulate, we check for errors, we debug. Shows you that okay, that's normally closed, so you can see it's energized. It's already energized. We've looked at normally open and versus normally closed, so you understand this now. So now you come and say, all right, let's get out of debug mode. Let's go online. Now you can see our PLC is on stop mode. We want to say, okay, let's run. Now when you run, it wants to confirm, are you sure you want to run? Yes, I want to run. Now there's my machine, but now I must start using my machine. Now if to start my machine, there's the start button there. What do? I come and energize that. I have to first select it. I have to come and energize that by setting it on. When I set it on, remember the latch machine went on, but because this is a component of the machine, it also got active. All right, we have explained this with the latch, with the previous latch. Now we are able to start, but now we have remember previously we said this would run until Jesus comes, right? So, or until the machine breaks, whichever happens first. All right, so now if we want to, remember, we don't want to continue holding the start button, so we set it back to off and the machine remains latched on. So the machine remains latched on, machine keeps running even though I've released my stop button. There's no power going through the stop button anymore, but the machine itself is keeping itself on. We normally say this will be done by relays. In this case, it's done by soft relays, by software. All right, so now we come and say, okay, now we need to say stop. How do you say stop? By activating the stop button. So when you say hit the stop button, and you can see power falls away. We are not going to hold the stop button forever, so we are going to release it, set it back off, and you can see the stop button will be ready for power again, even though there's no more power because it has done its job. It has stopped the machine. You have to go back and restart the machine again. So this is how. Why I want people to understand why I actually had a special session for understanding the normally closed, because I'm gonna say something very creepy here because it's creepy that this is actually crap. All right, in real life this is crap. It's so creepy because this is actually crap. I've explained it so it sounds like so straightforward, and now I'm saying it's crap. So that's why I'm saying it's creepy. Why? Because normally this is true when I use if the push button I'm going to use for the stop function is actually normally open itself. If the physical button that you're going to use, if the physical switch you're going to use for the stop is normally open, then this is 100%. But if the physical stop button that you're going to use, the press button that you're going to use for the stop is going to be closed already, it means the physical power is going to reach and X1, and then when you connect it, and therefore it's going to break F1. What I mean is the practical stop in most cases, because in most cases the stop function is achieved with a normally closed push button. So normally our stop is actually normally open. All right, our stop is actually normally open. If I can change this, let me do this. Okay. If I can change this now to, can I even just change it there, or I just have to double click on that and say remember? Or another thing, if I use the statement load inverse xi means normally closed. So if I just remove the inversion there, just leave it as load, then it becomes normally open. Let's do that and you see what happens. Now it's normally open. The actual stop when we actually doing the practical part, you will see that the stop is actually when we program the stop, we actually use the normally open. Why? Because the physical button that's going to be used as a stop is normally closed. Creepy, right? So, but if we assume that our button is going to be, our push button is going to be normally open, then it's okay to use what? To have, I double clicked, to have our what? Our load inverse, which is the normally closed LTI, and it's normally closed. So let's get this one more time. I want to make it clear. For a scenario which is theoretic, there's no physical patterns here. Our normally open, our normally closed, our normally open will function as a start, and our normally closed will function as a what? As a stop. Works perfect, as we've seen, we've debugged, we've seen nothing wrong. We've had it or come out of debugging, we've had it online, and you've seen how it works perfectly. So stop mode, I run it, yes I want to run, and you can see it works perfect. There's my stop already letting power through. Now if I then set this on, the stop button is allowing power through until I remember. Once I press start, I must set it off because I'm going to release the push button. Now I can then come and say stopping means setting this one on. Energizing that one will break the what? But obviously I'm not going to hold it forever, so I'm going to have to set it off again. This is me now acting like I'm pressing the button and releasing it. Alright, setting on, pressing, releasing, setting off. So now, yes, for a theoretic scenario, it works perfect that our normally closed will be a stop. But in real life, in real time, when we are going to say let's wire a thing now, a PLC, and the component we are going to use is going to be a normally closed push button for the stop, to perform the stop function, then we cannot have a normally closed, because what that normally closed push button will do is allow power through. That power will be sent to X1, energizing X1, therefore acting like our S1 has been set on already, meaning it will be broken. It won't allow power through. So remember that difference. I will try to press it. I'm going to try and make more of an impression on this issue when you deal with the physical components, when you're actually doing the practical part. We are programming for now. We're going to look at the PLC. We're going to try to see whether this is true. But I can guarantee now that. So what do you do now in a test or exam scenario to be safe? Because in the test exam scenario, it's not a physical test, it's not a physical exam. For an exam scenario, personally, I would prefer it being open. But because for most this is treated as a theory aspect of things, you just have to make it. You just have to make it closed. Even in a situation where we are programming like this. We are programming now. Before we actually load our programs onto the actual workspace, we actually have to simulate and test, right? So if I try to, I won't be able to simulate right now. If I had used that stop there as a normally open, it would never work. Simple. Let's try it. I think it should be obvious, but let's set this on, meaning now No. I didn't want to set it on. I actually want to say what would happen if this was a normally open LT, not LTI. If it was normally open, how on earth in a theory environment would I be able to simulate this? Because now power will never go through there. If we say let's debug, it will tell me there's no problem because there's no conflicts. Fine, it will say there's no problem, even though there is a problem. Because now when you come and say, okay, get out of debug, let's check, let's put it online and run it. Now you will see, yes, I want to run. Now you will see it does not matter what I do here. All right, I set it on, yes, but because that part X1 is broken, it will never allow through. So for theory situations, we have to have a stop that is what? That is normally closed. All right. When we program our part we simulate and we're done, now we have to load it to the PLC. We have to change that stop to a what? To a normally open. Why? Because the push button, every input that is going to be normally closed would have to be what? Would have to be programmed opposite. All right, because that normally open would energize and therefore defeat the effort, defeat what we were set out to do. So bear that in mind. It will be clearer, perhaps, when you do the actual practice. Now, let's see if you like that. If you did, you prove it by hitting that like button, and then obviously also tell us where you are. We want to know who we are reaching out to them. All right, please assist with that, and please give us comments and likes so that the algorithm can promote us and make us available to a lot more people. Subscribe if you haven't, join the family, and welcome in advance. See you when we do some I will do some basic programs first. I will start by doing the little gates, and then we'll go to much more complex programs a little bit later. I hope that was nice. Till we meet again. Ciao, ciao.